Hi guys, this video is about the index laws, which is basically a set of rules for simplifying mathematical expressions that have indexes in them. What do we mean by indexes? Well, we mean powers. So if it's something to the power of something, then when we're talking about the index, we're talking about the powers. So you should have seen the rules before. I'll just run you through them quickly, and then I'll show you some examples. So the first one says that if you multiply two values with the same base, then we're going to add the indices, okay? The second rule says that if you're dividing two numbers with the same base, then you're going to subtract the indices. The third one says that if you've got a number in brackets raised to a power, and then you're raising the brackets to a power, then you're going to multiply those two indices. The next one says that if you've got two values multiplied together in brackets raised to a power, then you can raise each of those to the power and remove the brackets. And similarly if you're dividing. Now I'll just leave the last couple for now, and I'll just show you some examples of those first few. So the first one says that if we've got, let's say, 3 squared times 3 to the power of 5, then we're going to add those indices, so we would get 3 to the power of 7. The second one says, let's say we had 4 to the power of 5 over 4 to the power of 2. Then we would subtract those indices, so we would get 4 to the power of 3. The third rule there says that, let's say we had 6 squared, and then that was being raised to the power of 4, then we would multiply those indices. So 6 to the power of 8. And then the fourth rule there says that if we have two values multiplied together, so I'm just going to make it 5x, and that was all being squared, so raised to a power of 2, then we would raise each of those two values to the power of 2 and then multiply the result together. So we would have 5 squared times x squared, or 25 times x squared. Alright, let's have a look at the last couple there, because they might be a little bit new for you. So this one here says that if you've got anything raised to the power of 0, then the answer is actually 1. As long as the number being raised to the power of 0 isn't actually 0, in which case it would be 0. So that's a little bit of a strange one. It's basically saying, let's say you had 5 to the power of 0, that's going to be 1. If you had negative 6 to the power of 0, that would be 1. If you have a half all to the power of 0, that would be 1. It doesn't matter. Whatever you raise to the power of 0, you're always going to get 1. And then this final law here is to do with negative indices. So let's say we had, so the rule says that if you've got something to a negative power, that's the same as 1 over that with a positive power. So let's say you had, well, let's go to 5 again, 5 to the power of negative 2. What we would actually do is we would make that 1 over 5 to the power of positive 2. Or in other words, 1 over 25. Or let's say we had 3 to the power of negative 3. That would be 1 over 3 cubed. Or another way of saying that is 1 over 27. And it kind of works in reverse as well. If you've got 1 over and something raised to a negative power, then that is actually the two of them cancel out and you just get a positive power. So if we had 1 over 2 to the power of negative 4, that's actually the same as 2 to the power of positive 4, which is 16. And then there's a particular case here. Just remember, if n is a 1, then it's just 1 over that value. So, for example, if I had 6 to the power of -1, that's just 1 over 6. So negative powers are actually an alternative way of writing a fraction. Okay, so that covers all of the main index laws. What I want to show you in a moment is some examples. So let's look at a few examples here. So this is kind of using the index laws in reverse. So let's say we want to write a value as a power of 2. So instead of writing the number 16, what we want to do is write that as as 2 to the power of something. Well, you've sort of got to break it down. So if we think about 16, 16 is 4 times 4, and 4 is 2 squared, so that's the same as 2 squared times 2 squared, or 2 to the power of 4. That's the way I would do it. You might be able to jump straight to the end if you just remember that 16 is 2 to the power of 4. What if we had 1/16, or 1 divided by 16? Well, we've just worked out that 16 is 2 to the power of 4, so that's the same as 1 over 2 to the power of 4. But based on our one of our last index laws there, if it's 1 over something, then that power becomes a negative. So it's going to be 2 to the power of -4 in this case. Okay, and then finally there, what if you had 4 times 2 to the power of n? Well, what we can do is we can replace 4 with 2 squared, just like we did above, and multiply that by 2 to the power of n. And now using our very first index law, because it's the same base, we can add the powers. So it's 2 to the power of 2 plus n. So that's just an example of using the index laws sort of in reverse. So for another example, let's say we had a mathematical expression like this, -3a cubed, all divided by b squared, and then that's all in brackets and squared. What if we wanted to write that in the simplest possible form without using any brackets? Well, we have to use a bit of a combination of our index laws now. So remember, the index law says that if we've got a fraction in brackets, then we can apply that power to both the top and the bottom. So we can sort of break that down and go -3a cubed all squared over b squared. And then another index law says that if you've got something in brackets raised to a power, then we can bring that power into the bracket and multiply the indices if needed. So -3 squared will be our first part, and then we'll have a cubed all squared. Our index law says then that we're going to multiply those two powers together. So we're going to get a to the 6, and I should have had b squared in brackets all squared. Little mistake there. And then when we expand that bracket, it's going to be 2 times 2, which is 4. So I'm just using a combination of the index laws now. Now, just to simplify this number down, -3 squared is going to be 9. Remember, a negative number squared will give you a positive value. So that'll be 9a to the 6, all divided by b to the 4. So that's probably the simplest form that you could possibly write it in. If we wanted to write it without the fraction, we could actually write that as 9a to the 6, b to the -4. Okay, so I will leave it there. Hopefully those examples will be enough to get you started. Just remember that all of the index laws always apply, so you can use them in conjunction with each other. And just remember to keep looking back at that table, and you should be able to work out the answer to most questions. Thanks for watching.